hope this works. Okay, so here is the way that we're going to do this, and I want you to do this in your notebook for me. So we're going to talk about so we're going to do constant of proportionality versus constant rate of change. All right? I don't even know if they can see that.
Can I do con and then like period?
Shh.
Or I just put con.
Okay, constant of proportionality versus constant rate of change. There's some similarities and there's some differences between the two. And so we're going to go all the way through constant proportionality first, and then we're going to go through all the way through constant rate of change, and then we're going to talk about the similarities and differences between the two, okay? Okay, so who remembers the equation for constant proportionality?
Jeez.
X plus or x k.
So y equals kx, or k equals y over x. Very good. Now, notice there's not a plus or minus anything on here, right?
Right.
There's no constant. It's just the coefficient and variable. That's how you know it's a proportional relationship. When it comes to equations, if there's nothing being added or subtracted, it's proportional. If it's just the variable and the coefficient, it's proportional. Okay? The y represents your dependent value, and the x represents your independent value. Okay? And then that k is my what?
Constant.
That's my constant of proportionality. Okay? That's what COP stands for. And CROC stood for constant rate of change. Okay? So, that's what it stands for. If I have a table of values, I think for yours, no, you can't do that. Hold on. I was trying not to make it too big because I'm going to graph it. So we'll just do it like this. Okay, so when you have a table of values like this, please don't talk. When you have a table of values like this and you're not given any other information, you're not given a word problem, you're not given an equation or a graph, you're just given a table of values. The way that you figure out, number one, is it proportional, is that y over x, and you do it for all three of your values. So you would say, okay, y over x, that's 2 over 1, which is 2. Y over x would be 4 over 2, which is 2. 6 over 3 is 2. And if all of these are the same, then that means yes, it's a proportional relationship. That's why your word up here is proportionality. Constant of proportionality. We want it to be proportional all the way throughout. We want it to be constantly proportional. Does that make sense?
Yes.
You need to have that written down, please. It's going to be flipped backward, isn't it, though?
I don't think you can see. Like it was kind of like this.
It will. It's
I
something
think there's a way you can crop it, at least on Android there is, where you can
It's
flip it.
totally going to be flipped
Android
backward.
printers.
No, it'll
All right,
flip
hold
it-
on.
It'll flip it
Hold.
after the video to like.
This
which
is
way
not a good
it's actually-
pencil.
Yeah,
Or
whichever
they-
way they face it.
Or
it'll
Miss
flip.
Bernard, they could put
Okay.
turn off like where the screen, like screen lock, so where it doesn't flip.
All that's going to do is change the direction. I'm talking about like mirror image right now.
Yeah, it's gonna flip the thing.
It'll flip it after the video's done recording.
Okay, if it doesn't, blaming you. If it doesn't flip, it's Graham's fault.
Yeah, Graham.
Hey,
You're
guys.
ground me, Graham.
Okay.
Get roasted.
Okay, now,
Get it down.
when, I'm going to go from my table to an equation. I'm going to give you a word problem that would work for this, and then we're going to graph it. Okay? I'm not going to write like the whole word problem. I'm just going to give you a situation. So my equation is y equals kx. I want the y and the x to stay the variables because that's what I'm plugging in, right? And it's the k that I'm replacing. So what would my k be?
2.
2. So it's going to be y equals 2x is my equation. Does that make sense?
No.
Okay, there's stuff on your hand. Okay. Back there, your hand was blue, like you had no circulation, and I was only slightly panicking.
He's a smurf.
We're good.
I choked a Smurf.
Okay, we're good.
What?
I strangled a Smurf.
All right, you're on video, maybe not the strangle conversation.
Oh, okay.
Okay, so now I can go, okay, let's think of a word problem for this. Maybe it's something like I get paid $2 a week in allowance. Nothing extra. I'm not buying anything. I'm not starting with a balance. I'm not getting $2 a week in allowance plus I had a birthday so I have extra money. It's not anything extra. It's just the $2 every week.
You'd be poor.
Okay? So that is a constant proportional relationship. Nothing's added, nothing's subtracted. I don't have an exponent. I don't have any extenuating circumstances. I don't have any exceptions. It's proportional. Okay? When I go to graph that, your graph doesn't have to be beautiful. It doesn't have to be perfect in this instance. Geez, like my little marker bag my daughter made me. It's odd and in the way, but I can't tell her that.
When
Okay.
your daughter walked
If my daughter walked in the room right now, we would have problems. She's supposed to be at Odell Elementary. So 1, 2, 2, 4, and then I don't really have room to do 3, 6, but that's okay as long as I have 2 points. Now, my specific graph is not perfect. It's not going to be like this amazing, you can see the line because I don't have everything evenly spaced. But would this be a relationship where you would have 0, 0? If I have 0 weeks, don't I have 0 allowance?
Yes.
So then there would also be a dot right here. 0, 0. The origin is where the x and y axis intersect each other. That's the origin, 0, 0. So when I go to graph this, it's going to go like this. And it's going to give me a straight line that goes through the origin. Does that make sense?
Yeah.
So if it is a straight line and if it goes through the origin, it is considered proportional. If it is a straight line, we can also call it linear. So it is linear and it is proportional. Some of your skills, some of the teaks that you're required to know this year is you're required to be able to determine proportionality from tables, graphs, and equations, and you're required to be able to determine whether it's linear or nonlinear from tables, graphs, and equations. Okay? Proportional, straight line goes through the origin. That's how you know from a graph. Proportional from a table, y over x is equivalent the whole way down. Proportional from an equation, nothing is added or subtracted. It's coefficient variable. Okay? Proportional from a word problem, there's nothing extra. It says it's this much for this, period. What?
I ran into this problem. I think there was like 2 points where there was where they were like straight across from each other, like you put a line, and then the others couldn't go in a line. That wouldn't be.
So if it was like this,
Yeah.
like it was going this direction and then it turns, if it ever changes direction, it's not linear, so it's not proportional.
Okay. So linear is basically proportion.
It's proportional and it's a straight line. Now you can be linear and non-proportional, and that's what we're going to do next. But if it's going to be proportional, it has to be 0, 0 straight line.
So it has to go through the origin.
All right, so let's look at constant rate of change. I'm going to try to do it in the same kind of order so that as you're looking at your paper, it can go side by side. So the constant rate of change, okay, there are things that I love about math. There are things that I can't stand about math. And one of the things that I can't stand about math is the way that we have the same thing, and sometimes it's called multiple different things. And this is one of those instances. So we have the constant of proportionality, and we have the constant rate of change. We're going to then call it slope. We also will sometimes call it direct variation or constant of variation. When the relationship is proportional, we use a K to represent that. When the relationship is not proportional, we use an M. And I don't know why we have so many different ways of saying this. All I know is that I'm required to teach you all of them. Okay? That's what we're talking about. Okay? So the Y is still the dependent value. The x is still my independent value. You should be writing this down as I write it. The m represents your constant rate of change. And then that v represents something called the y-intercept, which is basically just where x equals 0. Okay, so I'm going to give you a second to write that down. Constant rate of change. That's the title of that section. Constant rate of change, crop. Constant of proportionality, crop. You got it written?
Yes.
Okay, let me give you a table of values for this one.
Because she has some supernatural powers.
I can't make one second.
All right, write down those values. Constant of proportionality said that my rate is going to be proportional constantly. The whole thing, constant of proportionality. It's constantly proportional, right? And it was y over x. Well, that's 1, 7, 2, 9, 3, 11, 5, 15. If I look at this one and I'm trying to decide, is it going to be proportional? So I'm going to do y over x. So I've got 7 over 1, 9 over 2, 11 over 3, and 15 over 5. Are any of those proportional?
Oh, 15 over 5.
They have to be proportional to one another.
Oh, okay.
No, none of them are equal. None of them are proportional. What does that mean about this situation? It is non-proportional, which means it is not going to go through the origin. That means that where x is 0, y is going to equal something other than 0. Okay? These are those situations, you see the plus b? These are those situations where I say like, I'm making so much a month, but then I also had this much already. Like I have this much in my savings account and I deposit $50 a month. That's this situation. Okay? So instead of figuring it out by y over x, we're talking about the rate of change. Does anybody know what the Greek symbol is for change in math and science?
No, I don't know.
It's a little triangle, and it is the delta symbol, and it represents change both in math and science. So we say that the rate of change is the change in y over the change in x. The change in y over the change in x. It's not just y over x. That's constant of proportionality. It's change in y over the change in x. So I don't so much care what x and y are. I care what the difference between them are.
2.
So from 7 to 9 is what?
Plus 5.
No, it's
Plus
not.
2.
Plus 2. Oh.
From 9 to 11.
I keep thinking 4.
From 11 to 15.
4.
From 1 to 2.
1.
2 to 3.
1.
3 to 5.
2.
Okay, so I'm not looking at y over x. I'm looking at change in y over change in x. So then this would be 2 over 1, wouldn't it? This one would be 2 over 1, and what would this one be?
4 over 2.
4 over 2. Well, we know these simplify to 2. What does this one simplify to? 2. So the change, the rate of change is constant. Do you see that? The rate of change is 2 all the way through the table. So the rate of change is constant. It is a constant rate of change. Okay? So here's the deal. Here's why I go all the way down the table instead of just looking at the first one. Because you may be asked, which of these tables represents a proportional relationship or a linear relationship? And it'll look really pretty on the first 3 or 4, and then you'll kind of just do 1 or 2 and say, oh yeah, that works, and that's your answer. And what they want you to do is that. They want you to say, oh yeah, that looks great, and circle that answer. But if you had gone all the way down the table, that last one is not proportional or is not linear. And so you need to go all the way down the table, whatever your table is, okay? You're never going to be given more than like 4 or 5 values in a table. It's not that hard to go all the way down it. You can survive, I promise. I've given you much harder work. So, back to our equation. The problem with this equation is we have 2 things to fill in. We have that M and we have that B. So what's my M? What's my constant rate of change?
2.
2. Right here. Changing Y with changing X was 2. Okay? But then to find that B, it's where X is 0. I have 2 ways to figure that out. I can figure it out from my table, I can figure it out from my graph. Which one do you want to do first? Okay, if I figure it out from my table, I need to think backward. Okay? What I mean by that is, if I'm adding 1 here, how do I get backward to 0?
Subtracting 1.
Subtract 1. So I'm going to subtract 1 to get to 0. So if I was adding 1 here, I was adding 2 here. If I subtract 1 here, what do I need to do here?
Subtract 1 there.
Subtract 2, because I want to keep it proportional. 7 minus 2 is?
5.
Where X is 0, Y is? 5. So my Y-intercept would be 5. Does that make sense? Yes?
Yes.
Wait, no. Yes. Oh, we should do 7 minus 2.
Mm-hmm.
Oh, okay.
You good? So this could be something like, something like Hannah has saved $5. She has $5 in her piggy bank, and she gets $2 every time she loses a tooth. So she already has the 5, and then she's getting 2 for every tooth that she loses.
That's why it's with the variable.
Huh?
Is X considered a variable?
Right. So then if she loses 2 teeth, then she has the $4 from the tooth fairy plus the $5 she already has, so she has $9, right? All right, let's look at it in graph form. I'm going to come over here, and I am going to try to be a little bit more exact with my graph this time because...
Yeah, can they see that?
Yeah, it's on. Yeah, it's on there. I'm going to be a little bit more exact on this one because it matters as far as getting my Y-intercept.
Write that down.
You need to do a rough sketch, yeah.
I'll do my best.
Okay, that's all I ask. I don't know why we have to keep making pigeon noises while the video is running.
Yeah, no one.
Okay, so here's going to be my lines. You don't have to be as exact as I am. I'm being exact for you guys so you see what I'm doing. Okay, so when I go to graph this, I've got 1, 7, and then 2, 9, and then 3, 11, and I'm just going to stop right there. Okay?
So it's linear, not
Right, it will not be proportional because it will not go through the origin, right?
Wait, how many splits are there?
You have to, there's 4 total on the table. You need to have at least 2 to graph a line. As long as you have 2, you're good.
I'll tell you what, like, the graph.
Oh, I just did 12.
Oh, 12.
Yeah, but you can do however you want to. Okay, so it's not proportional. We know that. It doesn't go through the origin. Is it linear?
Yes.
Yes, and it's linear. If we have a constant rate of change, it's going to be linear.
So, would you call it like linear, non-proportional?
Exactly. You would call it linear, non-proportional. Now, how do I figure out from my graph my y-intercept? We said it's where x is
0.
okay on my graph. Where is x 0?
Or left one, bottom.
Where is my x 0 on a graph? On any graph? At the origin, both of them are 0. Where is the x always 0? If this is 1, where is 0? What is this line called?
The y.
The y Axis. The y-axis is where x is 0. The x-axis is where y is 0, right? So where x is 0, that means on the y-axis, where does my graph cross? This is the point 0, 5, isn't it? So this point right here is my y-intercept. That 5 is my y-intercept. So you always have access to graph paper, always. So whether you want to graph your stuff to find your y-intercept or whether you want to work backward in your table, it doesn't matter to me. There is a third way to do it, but I really find it to be the most confusing of the 3 ways, and I would rather wait until you're a little bit more confident in these equations before I teach you that way, okay? We will eventually have to learn it, but I would rather wait a little bit until you're a little bit more confident with all this rather than overwhelming you, okay? All right, so make sure you have this written down, and then we're going to go over your homework questions.